Welcome, and today we're going to talk about jet pumps 101, both shallow well and deep well jet pumps. And one of the things I often hear a comment about jet pumps is that why are we still talking about them? I mean, everyone knows what they are, everyone knows how they run, and they're pretty simple machines. In fact, they're pretty outdated, is what I hear. And I don't like to hear that. Jet pumps are actually making a bit of a comeback. Jet pumps are very practical. Yes, they are older technology, but let's be honest, compared to this, so is my father's old hunting rifle. It's a Springfield 1913 bolt action 30-06, but that's been sporterized, put in a sporting stock on it. It's got a scope, and even though it might be that old, she still fires true, and I'll tell you, she still drops a deer reliably at 100 yards. So just because something's old doesn't mean we shouldn't respect it and understand it. The other thing I'll tell you too, and keep in mind, when you're talking about jet pumps, I had a conversation with a man who was a driller, and he installed a lot of 4-inch submersibles. And he was losing his market share to public water. The municipalities were growing, and they were providing water. And he was bemoaning what he was losing. And I said, well, why don't you think of it this way? What might you be gaining? And he said, what do you mean by that? And I said, well, what's the average pressure in that subdivision, for example, you're talking about? He says, oh, it's usually about 55, 60, but in the morning, well, there's so many people there and the pumps can't keep up. It maybe hits about 30, 35. I said, oh, well, do they permit booster pumps? He says, well, I can check in on that. I'm sure they would. I said, well, if they do, why are you worried about what you're losing? Think about all those houses that need booster pumps now. And jet pumps do a very nice job of that. As well, one of the big applications you're seeing these in is places where they use this recycled water, this reclaimed water. Florida, for example, the sewer companies have learned a way to be profitable, or more profitable, I should say, in that they've learned that if they clean up the water a bit, but not fully to potable, but basically clean it up, sanitize it, filter it out, and return it back to the community through that purple pipe you often see when you're talking about reclaimed water, and they send it back out into municipalities for irrigation purposes. Not for drinking, of course, but for irrigation purposes. And often the municipalities send it out at lower pressure, sometimes as low as 25 psi. And so jet pumps in particular are seeing a new life, so to speak, in that they're being used to boost that pressure up for the irrigation system. So now that we know that, let's talk about jet pumps. But before that, we always do our little housekeeping here. Let you know what's going on with the educational portion of what we do here. Of course, we have the Pentair Learning Center. Now, any of these opportunities, if you go to any website, thestayright.com or theberkeleypumps.com, under the resource tab, you'll see on the left-hand side there's educational opportunities, and those are all there. The Pentair Learning Center will have these live recorded webinars put on there on a regular basis. As we produce them, we will put them out there for you. You'll also have interactive learning modules, and you know the best thing about this, there's no charge. So sign up, take advantage of it. We have the Pro Dealer program. One thing I want to point out on that Pro Dealer program, especially for you installers out there, is that bullet point labor and extended warranty programs. You want to learn more about it? Dial in at www.pentairprodealer.com. Pentair Access Portal, that is out there for all of your dealers and distributors. Gives you 24/7 access to product availability, pricing, order status, etc. Give us a call at 866-880-3771. Miss Amy there, she'll be happy to help you. Last but not least, we of course have factory schools here in Delavan, and we of course have them out there Grand Island on a regular basis. We'll also be trying to do some regional ones here coming up in 2018, we're hoping to do, where we'll be going to your location. Often these count for CEUs, so check with your local states on that. To register, again, you do it right online. Water systems and ag is offered, and they're often a lot more hands-on than you would get if you were to go to a normal seminar per se. We try very hard to keep you moving. I don't like to let you sit more than about 90 minutes, so if there's about 90 minutes of class time, I'll guarantee you have about a half hour minimum of lab time. So you're not going to just sit there. You're going to learn, and you're going to get your hands on the various equipment, including the PID, the Pentec IntelliDrive. Give you some time with that. Talking about jets now, let's get into the heart of it. One of the things I tell people is it's a two-pump system. It literally is. You have your centrifugal. Your centrifugal has the impeller which moves the water. The impeller imparts velocity. The volute case or the diffuser then imparts pressure by changing that velocity. Not getting into the whole lot of particulars, we all know Bernoulli's law. If pressure goes down, then velocity probably went up. If velocity goes down, pressure goes up. It's an inverse relationship. Remember that as we talk, because part number 2 to a jet is, of course, the jet package. Now, a lot of people think that this is a booster only, but I want you to understand this is a pump in and onto itself. Okay, and I'll highlight that later when we talk about a tailpipe. But one of the things that a lot of people comment is that jet pumps are inefficient. They're old technology, blah, blah, blah. Well, one is that they do serve a practical purpose. We just talked about boosting, for example. And 2, yes, they do sacrifice water to produce pressure. So let's explain this. Now, first of all, I want to make a differentiation also between shallow well versus deep well. Shallow well, because of atmospheric pressure, we can only pull from a maximum of 25 feet. Now, I've heard some people say 27 feet. That's fine. I'm a conservative guy. Anyone that knows me knows I'm pretty cautious. So I recommend 25 feet or less. Often the nozzle and venturi with a jet pump is often built into the pump. It doesn't even have one, for example. I know one of our retail divisions out there, Cymer, it was very hard to tell that it was a jet pump. The jet actually was sideways in the body. So often, though, the venturi and the nozzle and a dedicated shallow will be built into it. If you're using a convertible pump, meaning it could be used as a deep well or a shallow well, make sure you have the right nozzle and venturi combination. You have to pay attention there. Now, the other thing to remember about a shallow well pump is you really don't need that recirculation valve. In fact, you leave it full open during shallow well applications. Now, I've even had customers that have damaged them. They're plastic. I admit it freely. And if you damage them, don't sweat it. The shallow well, you can just put a pipe plug in there. Don't worry about it. When you're talking deep well, remember a deep well now, you can pull from greater than 25 feet. But it's going to use nozzle and venturi. And you have to make sure the nozzle and venturi are selected properly for the pump, the depth to water, and the horsepower. So there's factors you have to keep in mind there. Priming it will be more difficult, and you will definitely have to use that recirculation valve. When in doubt, read the factory manual, RTFM. Okay, now let's get back to shallow well pumps. And like I said, shallow well pumps, often the jet, as you see here, is built right into the nose cone. You won't even notice it. Meaning that these little snouts that are sticking out is where you have the nozzle and the venturi package buried into it. When you're talking about a convertible, on top you'll see the pressure gauge. To the right of the pressure gauge, you'll see the discharge, and then further right you'll see that recirculation valve, which you will have to use for a deep well, but mind you, as a shallow well, you'd leave it full open. The package would then bolt to the front of the pump, making that pump, which is, until you put a package onto it, is a straight centrifugal. Now, a little note too here is that I had a customer one time that it was burning up centrifugals. And it's because he was pulling the water from an open body of water to a tank to recirculate it through a cooler, a geothermal system basically. And every now and then, because the water level would get a little vortex in action, or might be low enough to do that, or there might be some wave action, the pump would pull air, and with a straight centrifugal, as you know, it would lose prime very quickly. So what we recommended was, instead of using that little J series, switch it over to the SL series, and the SL series, if you don't put the nozzle and venturi in and you just plug off the 1-inch, now you use the 1-inch for suction, you now basically have a J series, but the neat thing about it is it's now self-priming. Because you went to the S series or the SL series, now you have that big head that is shown here that has a little body of water over it, so it can recover should there be a little air or vortex in action. Makes it a better pump in that circumstance. So it's interesting how customers use our pumps. I always found that very interesting. When you're talking about a jet pump, why is it so efficient? If you follow the arrows here, you notice that a portion of the arrow, of the flow of those arrows are going to the nose cone and do a U-turn into the nozzle. Now at the nozzle, it's kind of like the nozzle is the thumb over the hose trick. It pinches the water, squeezes the water flow off so that the water jets through the next section, which is your suction, at a high velocity. And now remember, I just spoke about it earlier. With Bernoulli's law says if velocity goes up, then pressure must go down. So we create a low pressure zone there that helps draw the water in more efficiently. Then it jumps the gap, that stream of water then goes into a venturi. And the venturi is kind of like a trumpet, where it starts very narrow and gets wider the closer it gets to the actual impeller. And as the water travels through there, it's at high speed, and suddenly the passage opens and it can slow down. And remember what we just said, opposite relationships with Bernoulli. So if the velocity is allowed to go down, pressure goes up. So what a jet package and a centrifugal pump are doing in connection with each other is you're sacrificing the flow. It could be as much as 2/3 of the flow. But you're going to sacrifice that flow to send the water down through the nozzle, jump the gap into the venturi, and effectively you can often triple the pressure or more. You can build much more pressure and pull water from deeper depths in an example of a deep well. And we'll give you a better example of deep wells and how they work here in the upcoming slides. So the reason we're doing this is we're sacrificing flow to build pressure. Now, a lot of people say, but Dan, we have 4-inch pumps now. Why are we even bothering with jets? Because jets are an older technology. And one of the things I'll tell you guys who keep wanting talking about submersibles is if you have a 2-inch or a 3-inch well casing, what submersible are you going to put down there? You won't. You got to go with the deep well. And we'll talk about that here in the upcoming slides. Looking at the side view of a jet, you see the darker arrows there, at the very bottom, they float from left to right, do a U-turn into the nozzle. Now, with the arrows, we're showing you how the nozzles had a higher flow at a slower rate, and they're pinched off by the nozzle, and so they flow through their very high rate of speed, creating that low pressure zone, which then pulls water in and pulls the check valve. It then goes through the venturi, which starts out kind of wide to catch the flow, but it pinches off very quickly and then reopens like a trumpet to allow that water flow to go slower again. And remember, if we pinch off the water and have high flow, we create a low pressure zone. As we go into the venturi, we do the opposite. High velocity turns into lower velocity, and the pressure thus must be boosted. Okay? That's how that works. Now, points for troubleshooting. With a jet pump, if you get it out of the box brand new, you install it, and it's only building about 25 pounds of pressure, the first thing I'm going to ask you is check your voltage. Because remember, the pumps come pre-wired 230. If you put 115 into a 230 volt motor, it runs half speed at best if it doesn't trip the thermal overload, and it only builds about 25 pounds of pressure. Now, if the voltage checks out fine and we're still convinced that everything's plumbed properly, then if the nozzle is blocked, we're not pinching the water anymore. We're running a straight centrifugal basically. The water will still possibly flow into the pump because remember, a centrifugal pump can pull water too. It doesn't need the jet to do so. A centrifugal by itself can pull water, but it won't build pressure. Okay, so that's a tip that if you have a pump brand new out of the box, first check your voltage, then check your venturi. If this is an existing pump, say you're firing up for the 5th spring, you've had it in there, like I say, 5 years, this is your 5th season you're going on, you fire it up, you just can't get it to prime, you can't get it to build pressure, there's no air leaks, you've checked your voltage, everything's fine, then most likely your nozzle is blocked. When you do installations, first and foremost, I want to tell you that these drawings are not to code. These are for educational purposes only. Now what you see on the left, the first drawing here, that is a driven sand point. And I'll tell you, a lot of municipalities don't allow these anymore because literally it's a hollow nail that you just drive in the ground and draw water. What I mean is that driven point in the very bottom has a hardened point attached to a pipe that is often scored or has holes drilled into it with some screen material to protect the debris from getting in. And then you have drive couplings that attach the pipes together, allowing you to force it into the ground, drive it in the ground with maybe a fence post tool or maybe a pneumatic tool of some sort, and you punch these in the ground. A lot of wills were produced this way with pile drivers, and they just pounded the 2 or the 3 inch casing into the ground. Now, one of the comments I'll say about this is that these are often not allowed because bad things can happen very easily. What I mean by that is in one state that allows you, and Wisconsin's one of them, you can still buy these at the local farm and barn type of stores. If the local code permits it, they sell them. That means anybody, including the average homeowner, can buy one. And we literally had a homeowner that bought one of these and then was complaining about how the water was poor, there was poor quality water, it was even testing bad. And when we asked him enough questions, we found out that this man took the driven point, buried it, or drilled it into his backyard, and guess where his leach field was for his sewage system? In the backyard. Guess where he put the point? Right in the middle of the leach field, because boy, it wasn't that far down before he hit water. So that's why a lot of codes do not permit these anymore. Where they're often seen is that a lot of people will use this driven point rather than use the illustration to the far right here that shows the basket for an open body of water. If your code permits, you can pull from an open body of water. Always check your code, okay? Don't trust the factory. Local code is always the key. So even though we show you how to do it, it doesn't mean you should do it. But that drawing here to the right, we have the foot valve, and you've got to protect the screen around it. A lot of people don't want to build that, so they use a sand point to put it in an open body of water and use the sand point as the filter. As you can see, a shallow well can pull from a driven point. It can also draw from a well very handily. And again, I have customers thinking, I know as I say this, why again are you talking jet pumps when obviously that's a 4-inch well? And if that well were partially collapsed, or it has a bend to it, or it's damaged, or there's just enough buildup that that 4-inch pipe, you cannot get a 4-inch pump down there anymore, rather than abandon it, why not use a jet pump? So yes, a lot of customers use these for wells. That last drawing on the far right, like we discussed, we point out now in the 2 right drawings you have foot valves, which means priming is very easy. We still recommend a priming tee out near the wellhead or the water source, so you can use 2 points to fill the piping. But that far right picture, like I say, you can draw it from an open body of water if your code permits. But remember, always your priming tee. Now, the disadvantage of the far left drawing, the driven point, is note that there's a check valve, there's no foot valve. So anything below that check valve could possibly be air, so priming could take a little longer. So that's how you can use them as far as installation into the wells. When you get into the home, I'm going to get on my soapbox here for a minute. And a lot of people do not install pressure relief valves. Now again, these drawings I want to show you, these are drawings, and actually they're depicting booster applications. So if your local code permits, you can use these for boosting. But I want to point out these drawings here. We have very nicely drawn in there the pressure relief valve. Why wouldn't you install one? One customer said, Dan, you know it and I know it. I can pull out your catalog. The maximum pressure that S-Series pump can build is, say, 72 psi. It will never hit 75, which most pressure relief valves are set for, and below. So why should I install one? Very simple answer. CYI. Cover your interests. Okay? You got to protect yourself. Meaning this. The pump could go into runaway condition. Initially, it will only build about 72 pounds of pressure. But left unchecked, you can form steam in a pump like that. And I know a lot of guys would tell me, no, not that much. And I know all of us have seen those pictures of the PVC that's blown up like a big balloon before it blew out and the water escaped. Imagine how much pressure and how much heat is involved in there. That pressure relief valve better be there. Because here's the simple reason why. are you going to feel ridiculous to go in front of a judge and say, Your Honor, I didn't want to spend the $5-10 for a pressure relief valve for the customer and protect his home. I didn't find that worth the investment to make. Because that's basically what you're telling me. For the $5-10 that a pressure relief valve costs you, it's cheap insurance. Install them. Even if the pump is outdoors. I know when I teach or I'm on the work site, I'm always telling the customer pressure relief valves, okay? Because the bad news is every year more of those things called lawyers graduate from college and they make money suing us. So let's just do that simple thing. Now when you talk about priming, if you have a lot of pipe and you don't have that T outside, remember you got to pour enough water to fill the pump and all the plumbing going down into the well, which in a shallow well application might not be that terrible. Now on the drawing to the left, remember if you have a convertible jet pump and you're running it as a shallow well, open up that regulator valve and leave it open, okay? Just leave it open. So we fill the pump with water. We take the funnel out, we put our little pipe plug in and seal it off, and we're going to start it up. And when we start it up, we're running water through the nozzle and venturi. It creates that low pressure zone and it pulls the water up. As you see in the drawing here, there's various nozzles and venturis, and that's how you prime it. Now, one of the things I'll give you a quick caution on is that when you prime, don't be surprised for the pressure to jump up to 50 and then drop down again and not build pressure, because often you're cleansing the pipes, you're pulling all the air out, and if you ever go to like your ice maker and draw water from that ice maker in your refrigerator, and the glass, which is smooth as silk, you think, has all those little bubbles stuck to the side of it. Same thing is here too. So it's not uncommon that you lose pressure, stop it, open up the pipe valve, and the air that's trapped in the water will be whipped, and it'll be like whipped cream. So you'll open it, you'll see that little white foam, pour water in until it's gone, reseal the system, she should prime up again, no issue. Now, in this drawing, what we're showing you here to the left is the shallow well. I want you to understand, first of all, the venturis are not that long. So if you have multiple choices, if you see very long venturis over about 2.5, 3 inches long, they're probably for a deep well application. Now, you're probably wondering, why do I keep talking about multiple nozzles and venturis? And depending upon the manufacturer, Stay Right in Berkeley, for example, we have the CK packages. And the CK package was a young man that was hired by us years ago named Corey Coles. And Corey Coles was hired for the sole purpose of looking at our jet packages, which we had a huge number of, and trimming down. What do we really need? And what he found out was with a combination of 2 or 3 nozzles and a combination of maybe 2 to 5 venturis, he could cover a larger series of pumps. And for the cost of what those pieces were, let's add those together, put them in a big package with proper instructions on which nozzle and venturi to choose for the pump you're using, and sell them that way, so we had less jet packages on the shelf. Now what that means for you is that you have to RTFM, read the factory manual. Those kits come with a chart that will tell you what model number pump you're using, what horsepower, and if you're using it as a deep well versus a shallow well, a deep well will tell you which nozzle and venturi to use for the depth. The shallow well doesn't worry about depth, but it still tells you which nozzle and venturi to use per the flow and horsepower you're trying to achieve. Okay, so make sure you watch that. I tell customers, when you get a Corey Coles package, those are not extra parts that are duplicated, and one customer was convinced of that. He says, well, you use those cheap plastic, that cheap plastic in there, you got to send us 2 or 3 pieces each. No, we don't. No, we do not. In fact, typically if you break a nozzle, it's because you were cleaning it improperly, and we'll talk about that later. So you have your nozzle and your venturi, and make sure you got the proper ones. Now, some kits, depending upon the manufacturer, they might already be installed in the jet. Don't worry about it. Now, the other thing you have to pay attention to is on a shallow well, is it drive over suction meaning the 1.25 inches is over the 1 inch, or is it suction over drive where the 1 inch is over the 1.25 inches? Here's the easiest way to understand where to line up the holes. The venturi must go straight into the impeller. So when you're attaching this to the faceplate or to the bottom plate, the venturi lines up with the impeller. That's the simple answer. The other hole is then the drive line. Okay? So don't worry too much about it. Now, if you look at the deep well insulation, you'll notice the venturi is very long because it has to build more pressure. We're pulling water from deeper depths. And so that venturi is often longer. Now, a lot of people will ask me, on that venturi, there's these 2 notches right on top. What are they for? Is that for performance or something? And the simple answer is no. That's where you can lay the blade of your screwdriver across the top of it, and then it makes a big T-handle to help you unthread that. Because if you can imagine, if that venturi's been in the water for some time, there's some lime and scale buildup material that might make it hard to break free the venturi. Now, I know one customer said, but Dan, there's a nut. You can plainly see it in the drawing. There's a nut molded into it where you can easily put a monkey wrench or a pipe wrench. And the answer is, yeah, you could do that too. You could do that too. But we give you a couple options on how to remove it. Looking at the proper flow with a deep well now. And it's true with the shallow well, but this is a deep well application we're showing here. We have the 1 inch line where the water is flowing down. That water comes flowing and crashing down and makes a U-turn, and then is pinched into the nozzle where it's forced to create high velocity. We increase the velocity, and that makes a low pressure zone in the jet package, which creates suction and then draws water in. Then that water at high velocity is shot through the venturi, which you can see the venturi has a large opening to catch the water, but is pinched off properly to match the flow, but then again opens up. That trumpet that we talked about earlier goes from narrow to wider, allowing the water to slow down again. And remember, velocity goes down, pressure goes up. Plain and simple. Okay? Why it matters how to match them up properly. If the nozzle's too small, you got that Corey Coles package and you just put in any one you felt was right, that water would come down and be pinched off and shoot through it at high velocity. It would create a little bit of a low pressure zone, but because there's no flow restriction going into the venturi, it immediately sees a larger opening and tries to start building pressure, but can't because it's not proper. And so you don't get pressure. You might circulate the water, but you're not going to build pressure. Now again, in the center, that's the correct drawing where we matched our nozzle and venturi to build pressure. If the nozzle is too large, as in shown in the drawing again to the right, we're using a Corey Coles package and we mismatched. So we have the venturi, it doesn't pinch the water off. The water then hits the smaller opening on the venturi and bounces and doesn't flow through it properly, building pressure. So again, we don't build pressure, but we may circulate water. So if you're not building pressure, okay, and especially if this is a brand new installation and it's a CK package, or whoever's manufacturer you're using, it gave you multiple options, read that factory manual, okay? Read the manual, because I can't think of a company that just gives you parts without any instruction. At the very least, you would hope they would at least give you a YouTube video or a website to go to get more information if they don't give you the actual instructions. Looking at how these are installed for a deep well pump. Okay, the drawing here to the left shows a 2-inch well package and a 4-inch well package. If you have a 2-inch or a 3-inch casing, congratulations, you have a 2-inch well or a 3-inch well packer going down there. Okay, you're not going to get 2 pipes to go down there. And what I mean by that is physically, and we have a better drawing of the single pipe 2 and 3-inch diameter on the far right here. So let's look at that drawing on the far right. And what I'm telling you is that there's no way I can get a 1-inch and an 1.25-inch pipe down that 2 or 3-inch pipe. So what happens is On the top, we have an 1.25" suction pipe, and we have a 1" dry pipe that goes into a special elbow fitting, which connects to the top of a 2" or a 3" well package system. And it uses the well casing itself as the drive pipe. So that 1" pipe flows into that elbow, and then water is allowed to flow around the suction pipe, but it's contained by the casing, and the water is driven down, does its U-turn at the jet package, comes up, and the suction pipe is now that 1.25", which is dead center, drawing the water up back into the pump. Now, the thing to understand about a 2 or a 3" jet package, they have leathers. Leather, when you put it in water, swells. So that jet package that's down there, it has these 2 leather cups that when they're immersed in water will swell and seal themselves off, meaning that anything above the leathers is the dry pipe that the water will come down and will be forced to go into the jet package. Anything below the leathers is suction. That's a suction pipe. And you can even put a tailpipe and draw water from deeper depths. And I will highlight tailpipes here in a moment. So I want you to understand that those leathers are sealed off in place. And it's important to know that, because if you set, and I'll tell you, I have very brave customers that will set a jet package 60, 80, 100, 200 feet. Now maybe not 200, but I've had them set it 60, 80 feet with plastic PVC pipe. Granted, they thread it. One customer says, Dan, I use schedule 80. I use schedule 120. I'm not worried about it. What I'm worried about is this. How do I get that jet package out of the well? The leathers are holding it in place. So I am physically pulling it out with a come along, maybe a winch on the truck, however you're doing it, winching it out using the 1.25" pipe. If it's PVC, I hope for your sake that those threads hold up and it doesn't separate. Now, the other thing I've heard people say, well, I use PVC, and then I won't mention it, but they put chemical X down the well to eat away at the leathers. Well, if it's going to eat away at the leathers, is it healthy for a human to have? Why are you putting poison down the well? I don't recommend it. I have customers that do it to this day. We purge the well, we check the well, and everything. I don't even want to go there. Don't go there. You pull that out. Now, here's the other side of the coin too, is that typically you're replacing the jet package because the leathers are bad anyways. If the leathers go bad, now that drive water is going right past the jet package and past the leathers and never making a U-turn proper to build pressure. So you're pulling it for that reason probably anyways. Now, the other word of caution is it's kind of like a champagne bottle. If you've ever opened up a champagne bottle or a wine bottle and you struggle with the cork, and all of a sudden the cork will let free or even just pops right out of the bottle and goes shooting across the room. When you're pulling a 2 or 3" jet packer, remember it's under strain. It's under pull from that winch or from that come along or however you're pulling it. And all of a sudden the leathers will hit a clean spot or be very close to the top or even to the top or break apart, and suddenly that pipe comes shooting out. So I caution people, it can be the nose breaker. My brother found that out many years ago out on the farm when we were pulling a 2" well. We weren't paying attention. He had a lot of tension on it. Suddenly that leathers gave, that pipe came out and caught him right between the eyes. So do be careful, okay? The 4" well. The 4" well will have an 1.25" and a 1" pipe going to the wellhead and all the way down the wellhead into the jet package assembly directly. Both of these units, remember when you're priming all the pipes, the 1" plus the 1.25". Now people ask me again, why are we using a 4" well package assembly and a 4" well? And like I discussed, is that well always straight? Is there partial collapse or damage to the well? Is there too much buildup to get a 4" submersible down there? I know they make 3" submersibles. That's always an option too. I won't deny it. But you also have the option of a jet package to go down there. Again, not to beat a dead horse, so to speak, pressure relief valve, make sure you install it. I understand that most jet pumps don't build a lot of pressure, but when they get into runaway condition, they do. Also note we do make pumps that are shallow well and convertibles. The MS series, that is a deep well shallow well convertible, and the HS series. And these actually have multiple impellers, remember, which means they do build over 75 pounds of pressure. So I would be cautious. When you're priming a deep well pump, you take that priming plug, and ideally in this case, because you're filling up both pipes, I would have one at the wellhead if possible, so I'm filling out there plus inside. The key to remember is make sure you have that regulator valve open. If you see that diagram with the screwdriver there and we show you loosening the regulator valve, which you do need for a deep well, that regulator valve does two things in a deep well pump. It makes an isolation chamber so we can circulate water and get the air out, because it pinches off the flow, and it also isolates. You see that hose there? It isolates the pressure switch. So when we're purging the system and trying to get all the air out, we close the valve down here, which I'll show you in a moment. We effectively have isolated our pressure switch. So we fill the pump with water. We have that regulator valve open to make sure it flows all the way down. We then close that regulator valve, and you're going to start the system. And you're going to start to circulate the water. And ideally, you want to see the pressure to shoot up and stay up. But often when you're talking about this type of system, you'll see the pressure jump up to maybe 50, 60 psi, and then it just lose the pressure. Because you're flowing water, scouring out all the air bubbles, and you're whipping that air, and air compresses very easily. So what you have to do is turn the pump off, take your priming plug out, open up that regulator valve, and that milky white froth, that's this air, you're going to pour more water until you get all that out, purge it, turn that regulator valve back down all the way to seal it off, put your pipe plug in place, turn it on, and it's going to build good pressure. That's what we're looking for. You want to shoot right up to maybe 55, 60. When you see it's holding, it shoots up and it doesn't dive right off again, then you start to open up that regulator valve slowly by turning it counterclockwise, to the point that you want to then see the pressure gauge needle start to bounce and vibrate. That tells you you're at the sweet spot of flow, and you give that regulator valve a quarter turn to seal it off. Now, I'll tell you my experience, and maybe it's because we're in Wisconsin, we don't have very, very deep wells. What we do is we open it, and if we open it all the way, we have an amp meter ready, and we read the amps on the motor. And if, for whatever reason, you can open up that regulator valve all the way, and you're still drawing water, and you're still hitting 50 psi and turning off clean, because you're really not that deep of a well, check your amps, make sure you're not overamping the motor. If you are, then close that regulator valve down a little bit to change the flow and the production, and often the amps will come back down. So that's where you always double check your amps. Don't just trust this needle right off the bat and consider the job done. Always proof the amps is my personal recommendation. So like I say, if you're lucky enough to get that valve to bounce a little bit, close that valve back down a bit so the needle stays rock steady. Check your amps, and if you're good on amps, you're good to go. You've primed the pump. Now, here's that tailpipe I was talking about. And I want to emphasize, understand that jet setting where we set the jet package, okay, that's another pump. It can draw from 33.9 feet in a perfect world. Now, of course, we don't live in a perfect world. So, but it can still draw. Now, where this is often used is in areas where they might see a drought condition. They might punch a well 160 feet, and in the spring, the water might be at 30 feet. And so they buy a pump, maybe a 3/4 horse, maybe even a 1/2 horse, and they set the jet package down to about 60 feet. Because it's 60 feet, when they looked at the jet package combination to the horsepower, say that 3/4 horse, they saw that they should be getting 10 gallons per minute or better at that 60 feet of where they set the jet package. Now, I said at spring they had 30 feet of water. It's early spring. Everything's thawing, water's flowing freely. March comes along, April, May, and you start to get into the drier season, and the water table drops, but not that much. It now settles out to about that 60-foot mark where they're getting 10 gallons per minute. But then the drought hits, July, August, and the water table drops. Because you use a tailpipe, and a tailpipe is threaded into the jet package assembly, and it's 35 feet long typically with a foot valve at the end of it now. So we take the foot valve off of the pump jet package, the low jet package, we take it and we put it at the bottom of our 35-inch long pipe. Why 35 feet long? Because we can only draw water from a maximum of 33.9. So if it's 35 feet long, we should ideally circulate water but never lose our prime. Now, what the jet package does is, I told you, it's a pump. So the drought gets worse and it goes from 60, it drops another 10 feet, down to 70 feet. Well, if you look at this chart, if you're 10 feet below the jet package, you're still getting 80% of your flow, or 8 gallons per minute. If it progresses to its worst case scenario, let's say 29 feet, it drops below the jet package, meaning that we're now a total of 89 feet below where it normally is, okay? So we dropped down 89 feet, where water typically was only 30 feet. We're still getting 1.7 gallons per minute out of that 10 gallons per minute we normally got. Now, I know some people will say, Dan, showers need more than 1.7 gallons per minute. And that's true if you have one of those showers that doesn't have the water saving little plug in it, which I know myself when I built my home and plumber put in the quote proper shower head. The first thing I did when he walked out the door, that shower head came off, that little restrictor came out, and I was back up to about 4 gallons per minute. At 1.7 gallons per minute, that's not much water, and that is true. And that's where you as the professional work with the customer and you get multiple tanks together, or maybe a storage tank, but you do something so that the customer can learn how to budget his water. So they know, for example, in the morning, if they're showing 50 psi on the pressure gauge, that the tanks are full, and you have 120-gallon tanks, you have roughly 35 gallons of drawdown in each tank. That means you have 105 gallons of water to work with in the morning for showering and such. So the customers learn to live with the system. But you can provide a better system by providing the tailpipe in certain circumstances. When you're looking to prime a pump with a regulator, now for example, our Myers brands often have these. In the Stay-Right in Berkeley, it's the HMS and the MS series have a regulator. It has a little nut on the back that compresses this plug. And I want to caution you, this is one that if you look at this drawing, you see where the pressure gauge is and it goes into that bushing. Even though it's going into a bushing, that's not much of an opening. In the drawings that we'll show you, it makes you think that opening is very big and I can pour water freely from a bucket very quickly into it. And no, you can't. So I want to caution you and understand that in this type of situation, you definitely want to put a priming plug somewhere in the plumbing that has a much larger opening, say a 1-inch opening, make it easier for you to fill. Because these are multi-stage units sometimes. The HMS and the MS series can pull water from 300 feet. So you could have 300 feet of pipe to fill. So that's why I want to make sure you kind of understand that. So you open this regulator to fill the water into the system. Okay, so we're pouring it in there, and if you see that drawing on the right there, it makes you believe that you've got an opening that's probably about 1 inch in diameter or 3/4 inch in diameter compared to the pipe maybe. That's where I would recommend on that, where the arrow is on that drawing on the right, that discharge pipe, I would put a pipe plug there with a 1-inch T or so I could pour water in much freer than in that smaller opening. So we have the valve open. That drawing to the left shows that we open up that regulator valve. We're letting water flow into the pump and down into the 2 pipes into the well. Okay, once we fill them, again, that low regulator nut, we're going to close it down all the way, and we're going to turn on the pump, and we're going to see the pressure jump up right away. If it dies off again, you probably know why it dies off. It's because we have that air issue, so you might have to purge it a couple of times. But we want to see the pressure shoot right up, and you have to watch the multi-series jet pumps because that pressure can jump well over 70 psi. So be careful. So it jumps, you start to back off the pressure gauge needle or the regulator, so the pressure gauge drops down. and you keep opening it until that needle starts to vibrate again. When it does, give it a quarter turn to steady it. But again, break out the amp meter. See where you're running on your amps. Make sure you're not going over the service factor amps, okay? You don't want to overamp the motor. So I proof it both ways. I do it by the regulator or the pressure gauge here, and then the last thing I would always do when the pump is running is I'd watch my amps to make sure I'm not overamping the motor. So you do that quarter turn, the needle steadies out, you check out your amp pull during the flow, and you make sure it's running properly. Now, that sounds nice and easy, but I can tell you I work with customers out in the field, and one of them gave me a shortcut, and he said, listen, doing it that way, you can multiple times have to stop, drain out that air that's trapped in there, and try to keep repriming it. A trick he does is, if in the drawing here, you see the drawing to the right, you'll see there's the mounting nuts or bolts that hold the pump down, and the one at the 7 o'clock position, right above it, you'll see there's a 1/4-inch NPT plug. That's your pipe plug to drain the pump for the winter. Take that out, and he puts in there a drain cock. Okay, so now that drain cock will thread in there, and you can open and close that to make draining very easily. You can also do his trick, in which he then takes a bayonet fitting and a length of hose, and he puts that bayonet fitting into the drain cock, puts the hose onto the bayonet fitting, and then runs that hose into a 5-gallon bucket of water. And so as he fills the pump with water and he's about to turn it on to start priming, he opens up that drain cock a bit. So now you're pulling from both sources. And sometimes you'll see he does this because you're pulling more reliable water and helping displace the water and the air better. That often, by using this trick, he can prime it up the first time. So that's just a little trick I learned in the field. One of the things I say to customers when I do these trainings, especially when I do them in person, is I encourage it to become a conversation. Ask me questions or tell me what you find in the field works. Because as you can see, I try to incorporate them into my trainings to pass on the information. So especially even after you watch this video, if you want to email us, you can always email us at training.institute@pentair.com and give us suggestions or things you've noticed that you want corrected or have found work easier. Okay? Always appreciate your feedback. Now, not to get into too much detail on this one, but this is a customer that had a shallow well and he had an old deep well, and he's trying to make the two work in conjunction. The first thing, and if you've had any of my classes, you'll notice that I would be counting fittings and noticing that he's well past the 9 fittings mark, which means he's creating a whole lot of unnecessary friction loss, and that's his first problem. So he's losing, and he's probably losing pressure and probably creating water hammer and creating a mess. Number 2, remember, a deep well needs a jet package down in the well with flow going down and suction pulling out properly. If you see that pump now, which is a convertible, that's our SL or our HL series. The jet package can be on the nose or it could be down in the well, but it can't be both. And he's trying to do both here. So what I tell customers is that creativity is great. I don't want to ever stifle creativity, but don't try to cheat the system like this. You just can't do it. Okay? Either you're running a deep well or you're running a shallow well. You're not running both at the same time. And last thing too on this drawing, that many fittings, you're begging for an issue. Water hammer and loss of pressure and such. So watch your fittings, okay? I want to thank you for your time. I greatly appreciate it. I know that your day is important to you, and the fact that you took some time out to share it with me, I greatly appreciate it. We also remind you, like I said earlier, all these are work in progress. Give us your tips and your information. Tell me what you want to see. Tell me what would help you make your job easier. Give us a line or a shout out at training.institute@pentair.com. I'm Dan Featherstone for the Pentair Training Institute. Thank you very much, and have a great day.